Okay, so this is a quick one. We have the mass to be 5, and we have the velocity before, or initial, to be 3i plus 4j, and we have the impulse to be minus 2i plus 6j, and we want to find the velocity after. So to do that, we have a formula: impulse equals mass times the change, or the difference, change in velocity, which is the same as change in momentum, because it's m times va minus m times vb, something like that. So va minus vb, and so we have j, we have vb, we have m, so we can find va. Va is, if you want to do it step by step, actually, it will be j is m va minus vb, mvb, and then take that to the other side, divide by m. To isolate va, you're going to get g minus, plus, because we take it to the other side, so m vb over m. So we're going to get, just add them, minus 2 plus 5 times 3, and 6 plus 5 times 4, and divide by 5 in the end. You're going to get 13 over 5 plus 26 over 5. This is I and this is j. If you want in decimals, you're going to get 2.6i plus 5.2j. What's the unit if you were concerned? Velocity, so it should be meters per second. Now the next one is exact same formula, it's just that we're looking for impulse now. So we have the initial, we have the velocity, we have the speeds, actually, speed before and speed after, and we have the mass, so we need to find the impulse. Now the impulse needs a direction. It's it's a vector quantity, so what you have to do is you have to figure out from these speeds their directions so that you can get them to be velocities. So with a speed of 20, so say some arbitrary, which means random, arbitrary direction, let's take this to be the direction that we started with, the particle started with. So we have a va, or vb actually before, because v before, I know it's confusing because you might say a then b, but anyways, v before, if you want, here, before, let's say points in this direction, the particle is going there, and then there's the bat, it will move like this, and so this will be v after. And since we know velocities are either negative or positive, one of them is definitely negative. So you just have to pick a positive direction. You can pick this one to be positive. So this one will be, if you want me, I'll write it here. This one to be positive, so this one will be positive, this one will be negative. And this matters because it matters your calculation. You're not going to do 25 minus 20 or something in that. You're not going to get 5 here. You're going to get their sum. You can put absolute value because in the end you're going to get magnitude. So you can get, so that everyone gets the same answer. But anyways, so va minus vb, so it's going to be 0.5 times va, this is v after, I said positive, so it's going to be negative for me, so minus 25, minus from the formula, and velocity vb is 20, positive, so and you get 0.5 times minus 45, you get here minus 22.5 newtons per newton second, I think, newtons per second. To double check the units, newtons per second. So in here, this is the negative, you want magnitude, so just put positive so that everyone gets the same answer, and there you go, 22.5 newtons per second, and we're done. Okay, so 2 things to keep in mind: the word coalesce, which means combine. So if you have a ball like this and another one and they're approaching each other, they will coalesce or combine. So say that there's something that's binding them now together, so that if they were to move, they'll either move both to the right or both to the left. With a combined velocity, it's the same. And not only that, second thing is to keep in mind directions. We're talking about velocities, momentum. It's a directional, it's a vector. So when we say this moves to the right and this moves to the left, surely they don't have the same speeds, but say both of them are 5, they will still not have the same velocities. Each one has a direction, so you have to keep in mind direction. It will mess up the entire formula. So pick a positive direction. So let's say I pick this one to be positive, to the right. So we'll have this positive velocity, negative velocity, and whatever we get here, which can be determined just by simply doing calculations. We will know whether it's positive or negative. So yeah, so we have the masses, we have the velocities, and we're only looking for after. So MA, U for initial velocity, plus MB equals MB plus MB, times the combined velocity, VAB. And then you divide, so VAB equals MAUA plus MB, it's just weird saying this, and MA plus MB. Now I'll substitute with you guys rather than instantly do that, because just to show you how the directions work, you can say. So mass, we know the mass is 2. The initial for A, this is A, this is B, or if you want to, anyways. So this is A, this is B. A is moving to the right. As I said, right is positive. For me, I pick that. Any arbitrary one works, because they're going to ask in the end for speed, which is devoid of sign, just so that everyone gets the same answer. So 2 times the initial for A, so A is going to have a positive one, so it's going to be 4, plus M, again 3, times initial for B, negative what? 5. Signs are important, again, cannot emphasize more on them. And just simplify 2 times 4 plus, or minus actually, if you want to do it quickly, minus 5 times 3 over 5. You get minus 7 over 5. What did I write for? Minus 7 over 5, which is minus 1.4 meters per second. They want speed, so 1.4 meters per second as the final answer. And so let's move to part B, ignore the fact that I said C. So we have the mass, we have the initial, we have the final, we're looking for impulse. We don't need to write the formula since we got used to it, but you know, if this is written or somewhat, you're gonna have to write it. And yeah, so the mass 0.5 times this after, this is after and before, or final and initial. I'm just gonna subtract these and add them, you know what I mean? It's just because like this minus this is the same as this minus this plus this minus this, you know, it's just algebra. So yeah, so 2 minus 4 I plus 3 minus 7 J, again no mistake, and this is minus 2I and minus 4J, and distribute the 0.5, you get minus I minus 2J impulse, and that's should be it. Why did they actually ask for the impulse not as a magnitude? Because you simply are working with vectors, and everyone will have to use the same vectors, so everyone should theoretically get the same result. So that's the answer for this part. Okay, again, the only trick is to use or to pick a direction. So we have a particle that's falling, the speed blah blah, and then here it has a stops, it just bumps and goes to rest. So the momentum will be simply, again, magnitude, because they know everyone will pick their own positive direction. Arbitrary, I'll pick up. No, it's actually useless. It's up is, you know, we only have 0, so I guess yeah, we can just stick to down being positive. Again, doesn't matter, who knows, maybe you'll get a positive, negative answer, who knows. So 2 times final, it's at rest, minus initial 12, positive, so 12, and oh, we got a negative answer, minus 24. Again, doesn't matter because everyone picks their own direction. And we want magnitude, so this is newtons per second, so this will be 24. Again, newtons per second, but in magnitude, so you're gonna remove the negative and it'll be 24. So part B, 2 particles P and Q of mass 4 and 2 respectively travel towards each other, blah blah. So we have P and Q velocities. So this is initial, after collision Q has velocity blah blah, so find the velocity. Okay, so we're given masses, we're given velocities before and after, except for one, after for P, and that's easy, just one variable. So MP times UP plus MQ times UQ equals MP times VP plus mq times vq. It becomes hard to say this quickly. So anyways, so just we want to find this, everything else goes to the other side. So vp equals mp. Let me just instantly substitute. mp is what? 4 times up is what? Okay, so we have to keep in mind directions. They do what? They travel towards each other. So assume this is p, assume this is q. You can draw them if you want. Travel towards each other, blah blah blah. We are given, oh no, we're given velocities. We're given actual directions with it, along with it. You see the negative here? So we don't have to worry about anything. Just immediately blindly multiply. So 4, let me just do something quick. 4 times up is what? 6 plus 2 times minus 2. And we're talking I. So I'm just going to write I here. Minus mq, which is 2, times vq, which is 3. Again, we're talking I here. And this is what? Again, this is I also. So it's a bunch of i's. So over mp, which is 4. And just do the simplification. Let me just push this down. So what do we get? We get 4 times 6 plus 2 times minus 2 minus 2 times 3 over 4. Wait, is that right? Yeah. So you get 7 over 2, which is 3.5 I. And that is the answer for this part. Newtons per second, we're looking for, no, sorry, meters per second, so yeah. Okay, so whenever you see you have a ball falling down from a certain height and rebounding, you're talking about conservation, most probably, again, not always, conservation of mechanical energy. And here again, as expected, we're looking for speeds before it hits the plane and after it hits the plane. So how do you start this? So first of all, since it's conservation of mechanical energy, so I can do k1 plus u1 equals k2 plus u2. Now, which one is 0, which one is not? So we're talking about the speed just before it hits the plane. So what is 1 and what's 2? What are these states? I call them states. What are these states? So k1 and u1 are at the state where the ball is about to fall, when you drop it for the first millisecond, you can say. u2 or k2, these are situated when you're just before hitting the plane. So when you're just dropping it, it has a speed of 0, a velocity of 0. However, its potential is mgh. Its k2 will be maximum, but its potential will be 0. It will be very near to h being 0, being the surface. So it will be just u1 equals k2, which is, this is mgh. You can say h1 because it has 2 h's, and half mv. You can call it what? V. I call it v, and the other one I call it v prime squared, just to keep the symbols different. And we want v, so v equals divide by m, multiply by 2, 2gh1, and then square root. And then if you want to find the value, it's the square root of 2 times g, 9.8 times h, which is 5. And this can actually be applied for multiple problems. If you have the say in the AP or something, you can do this much faster by just doing 2gh. But again, make sure that these conditions are what's happening. You're dropping it, and you're talking about before hitting, and this is as you, like the first second you drop it. Anyway, so it's 7 square root of 2. So if you want to find an actual decimal for that, it'll be approximately 9.9, I guess. Or if you, yeah, 9.90 meters per second. Anyways, and the speed, again, we're talking speeds, we're not talking about directions. The speed of the particle after it leaves the plane. So we know before, so we can get after. So now we have different states. We have different 1s and 2. Even though they're same numbers, they have different states. This one is before it hits. Now we have that, so we can use it. And this one's 0 because it's before hitting, right before, so it has an h of 0. However, for this one, state 2, it's just after it leaves the plane, which it's, how to say this, like it's gonna have the and so for the next one we want to find the speed of the particle just before it leaves the plane. So that will be basically state, so let me write them, k1 plus u1 equals k2 plus u2. This is before it leaves the plane, sorry, just after it leaves the plane. So it's like this, it hits and then it rebounds. The very instant it rebounds, this is state 1. State 2 is going to be where it reaches its maximum height. This is how we do conservation. So the first conservation we did here was from where it was dropped till before touching the surface. Second conservation in part B is going to be just after it leaves, so it hits it just after it rebounds. We're looking at this is state 1 and this is going to be state 2, maximum height. So yeah, we use that because we can cancel things. Like, let me show you what you can cancel. Just after it leaves the plane, its h will be somewhat 0, so you can say this is 0, and after, when it reaches state 2, maximum height, it will have a velocity of 0. It cannot go further, it will go down instead. So I'll just equate them, k1 equals to u2, and so half mv prime, I call v prime, because you know some velocity, it's not the velocity itself is not kept. If it's kept, it will fully rebound forever and forever, but it will not. So half mv prime equals, we have the height mgh, this is 2, so v prime squared, this is squared, so v prime equals, cancel the m's, times 2, so 2gh, 2 square root of that, so you'll get square root of 2 times 9.8 times 3. You're gonna get 7 square root of 30 over what? Over 5, which is approximately 7.67 meters per second. I'm writing in all forms. If someone out there wants in this form, say, or this form, then everything's here. Calculate the magnitude of the impulse. We want the impulse, so that's easy. So the impulse is, we have the speed. So I'll actually discard this because we're talking about speed. So m times v prime, I called it v prime, and the other one's v. And yeah, it's simple, just plug in. So v prime is going to be, I guess, yeah, in this one you actually have to take directions. Yeah, you have to take directions. You have to. Impulse, you have to. Because you have a minus here also. If you just subtract speed, you will get the difference, I guess, which is not what you want. You want the change. So what you have to do is pick a direction. You have it's falling like this, and then it's going up like that. Pick anything. I'm going to pick positive to be this one, so this is going to be positive. So after is positive, before is negative. After is positive, so 7.67, or if you want its form, just to get an accurate answer, you can do that in the calculator instantly. Minus before, which is, as we said, negative, because here we picked positive to be up, minus which one? 7 square root of 2. And just add that in the calculator. You can put your normal decimals, by the way, and just for anyone who wants accuracy, it's there, 7 square root of 2. And so you get 52.7. Yeah, 52.7 meters or newtons per second. And they want the magnitude, and it's already positive, so I'm just going to keep it like this. And that's 4. Okay, so here we have to use Newton's law of restitution, since we're given the coefficient of restitution. And also you can know from being given 2 masses, 2 speeds, initial ones, but not having anything about the final ones, so you have 2 unknowns. You also, third thing, you have to keep in mind direction. So let's draw a simple diagram to keep in mind direction. So they're approaching each other. I'm going to pick this to be positive, so it's going to have a positive velocity. This one's going to have a negative one. And we are ready to go. So conservation of linear momentum is going to be ma times ua plus mb times ub equals ma times va plus mb times vb. And the second thing is Newton's law of restitution. I just can't speak and write. Newton's law of restitution. And yeah, I'm too lazy to continue. So, and here is the formula. So v1 minus v2 equals minus e into, don't forget the minus. So minus e into ua or u1 minus u2. And 1 and 2 can be anything. In this case, a or b can be anything. This one can be a, this one can be b. So that means ab here. But you can swap them, so b, a, b, a. And you just have to keep the consistency. You can also swap the 1 and 2, it's the same thing. So if you do v2 minus v1, if you have ever seen someone do this, or a teacher, or a friend, or somewhat, again, correct. If you keep consistency, it will be right. So I'll erase this. We have our two tools. We have two unknowns, so we have to use systems. Let me write to the side. So this will be our system, these two. So let me simplify. So now again, keeping in mind direction as we simplify. So ma times ua, so 0.2 times 12, that will be 2.4, plus mb, which is 0.5 times ub, which is 2, so 0.5 times 2 is 1. Keeping in mind this is negative, so minus 1, equals, I'm gonna swap because it's annoying, so I'm gonna write here 2.4 minus 1 equals, this is the final, so ma, which is 0.2, va plus 0.5 vb. You're gonna know why I said it's annoying, because the other one's gonna align and it's gonna mismatch. va minus vb, because we don't know their values, equals, I picked, as you can see, I picked 1 to be a, 2 to be b, I will remain consistent, minus e, which is 0.5 here as given, and u1 is going to be 12 positive, that's why I did not care, minus, there's a minus here and there's a minus here from the other speed, so it's going to be positive, plus 2, so 12 plus 2, that will be 14, times 0.5, that will be 7, so minus 7. I just simplified. Now you can know we have two systems. Let me simplify this too. 2.4 minus 1, that will be 1.4. Now we just have to figure out what to do. You can do substitution, you can do linear combination. I'll do linear combination just by multiplying here by 0.5. Why did I do that? Because I noticed that here you have 0.5, here specifically actually, you have plus and minus. So, and I like adding, I don't like subtracting. So to actually cancel them with adding, and this is minus, this is plus, they have to have the same coefficient. So 0.5, 0.5. So it will be 0.2 VA plus 0.5 VA, so it will be 0.7 VA. Ignore because they'll cancel, equals 1.4 plus, this is why I like plus, minus 7 times 0.5, that will be 3.5. You're gonna get minus 2.1. And so VA will be eventually minus 3 meters per second, and VB is just substitute into this one, the simplest, VA minus VB equals minus 7. So VB, take this to the other side, take this to the other side, that's how we keep them positive, but do whatever you want. So VA minus VB equals minus 7. I just take them to the other side like this. Wait, did I do weird? Anyways, so yeah, I do it like that, like this. So VA plus 7 equals VB, and so VB I mean is simply 4 meters per second. You can of course do your algebra however you want. Anyways, so yeah, you can do your algebra however as you want. So as you can see, this is minus 3, this is 4. We're done with part A. Part B, the magnitude of the impulse given to each particle. So we have the change in velocities indirectly because we have the initials and finals, and we have the mass, of course, so we can immediately do this. So the impulse of, say, A, keeping in mind direction, again, keeping in mind direction. The good thing is these are velocities. We're talking about velocities, so they have their direction with them. We just have to keep direction aware of these ones. Actually, they annoy me, so let me just write it here with it. So minus 2 and this is 12, as we picked here. So now whenever I look at it, I know the direction. So the impulse for A, as written here, is going to be the mass, which is 0.2 for A, into its final, minus 3, minus its initial, which is 12, up. So it's going to be minus 2 times minus 15. So it's going to be minus 7.5. No, this is not 0.5. So you have to do this times 15, 3. So minus 3 newtons per second. And the other one for B is 0.5 times finals for minus 2, minus 2 actually, because minus from the formula, minus from the velocity itself, so plus. So 0.5 times 6, so you'll get 3 newtons per second. This makes sense because they bump into each other. Each one gives the impulse to the other, you know, that causes their speeds and, you know, the momentum to be conserved. So their impulses logically are going to be equal but opposite in sign. However, they want magnitudes, so you can actually avoid calculating the next one and just saying in magnitude these two are equal. These two are equal. And yeah, we're done basically. This is the final answer is 3 and 3. 3 for A, 3 for B. And we're done. Okay, so we know that we have two spheres, so let me draw them. So you have 1 and 2. Let me call this A, let me call this B. This one has a mass of 2.5, this one has a mass of 1.5. And they're traveling towards each other, so this is going to be their velocities, their direction. And blah blah blah. The heavier one, so this one, has a initial speed of 3. And this one has an initial speed of 2. But I'm gonna write minus 2 because I'm gonna pick my positive to be on the right. You can pick yours to be on the left, and this will be negative, this will be positive, but anyways. Write your signs, I prefer at the beginning, so that you don't have to come back to it and always double check the sign, so it's easier if you write here. And after they collide, the heavier one is at rest, so this one's gonna be with final velocity of 0, this one's unknown. You have to discover it. Here they ask you what's the speed of the lighter one. So you're going to use conservation of linear momentum. And so that will be, well, instead of writing the entire formula again and again, I'll just instantly write the numbers. So 2.5, the mass, times the initial speed or velocity is going to be 3. Plus, but there's a minus here, so I'm going to write minus. The mass, 1.5 times the speed 2, equals, again, 2.5 times 0. So that will cancel itself because it will be 0, plus the mass 1.5 times the final, which we don't know, so it will be like this. So VB is going to be equal to, just put the numbers, multiply, so 2.5 times 3 minus 1.5 times 2 over 1.5. You get 3 meters per second. It's positive, means to the right, and it makes sense because it cannot go through the ball. Physically, it's impossible. So the only logical meaning, if A is at rest, because if A goes to the back, it could make sense that B follows after. It is possible, but at a lower speed, maybe at a higher speed at the beginning, and then bumps into it again, who knows. But it's physically impossible for a ball to be at rest and for B to be to the left. It would have meant it went through it. So yeah, find the coefficient of restitution between the two spheres. We're going to use Newton's law of restitution. Again, don't take these abbreviations, just me being lazy. So Newton's law of restitution is going to be VA minus VB equals minus E into UA minus UB. And so we want the coefficient itself. So I'm going to distribute the minus, so I will reorder this. So it will be VA minus VB over UB, I distributed the minus UA. So if you want to see the substitution, if you're unsure of what to substitute, VA is 0, minus VB, which we have just gotten to be 3, over UB, which is, as we discussed, minus 2, minus UA, which is 3. You'll get minus 3 over minus 5, so 3 over 5, and that will be 0.6. And it makes sense because it's a ratio between 0 to 1, or yeah, from 0 to 1. So it makes sense that the value 0.6 is possible. So find the kinetic energy lost. Lost means you had earlier, you had, or before you had more than after. So if you want a positive result, because kinetic energy lost is a positive number, because you know you lost it, so you're just saying the value of it. So it's initial, the bigger amount, to get a positive difference, you do the bigger. So lost equals kinetic energy initial minus kinetic energy final. This is how we can always remember it. So I'm gonna, you see, it's half mv squared plus half mv squared minus half. So I'm gonna take out the half for each one if you want. So half here, I'll take it out the half, and here I'll take out the half. So half into ma ua plus mb is squared, of course. It looks like momentum, but you're doing half mv squared, half mua squared plus half ub squared minus half a v a squared plus b time. And as you put the b here, put the b, vb squared. Okay, now we can replace. So half, let me just instantly replace. So ma is gonna be, so half 0.5 into ma is what? Our mass is 2.5 times the initial, which is 3, so it's 3 squared, plus mb, which is 1.5 times 2 squared. You're gonna get the number 14.25 minus half, or let me just write instantly. So 0.5 into ma, which we discussed earlier, 2.5 times va, so that's gonna be we said 0, so I will ignore that term because the entire thing becomes 0. mb 1.5 times vb, even though it's negative, it's gonna be, oh sorry, wait, which one was negative we said? Oh yeah, actually it's ub, but it cancels anyways with the square. So yeah, anyways, 1.5, so vb 3 squared, and you're gonna get here 6.75. Subtract the two numbers, you're gonna get 7.5 joules. Again, because we were speaking about energy. So that's it for part 6.
So I'll give you guys a minute to solve basic question 7. Okay, so part A says calculate the speed of the ball just before its impact with the plane. So in this case, we need to consider the ball before its impact with the plane, the movement of the ball before its impact of the plane. It's mentioned that it falls from a height of 135 centimeters, so we need to consider that. So it starts from 135 and ends at 0. So we can just apply the formula u1 plus k1 is equal to u2 plus k2. Now they mentioned that it falls from rest, so the velocity would be 0, so as a result we can cancel k1 out. And we said here that it falls to a height of 0, so mgh would be 0, so we can cancel u2 out. That leaves us with u1 is equal to k2. We get mgh is equal to half mu squared. U because it's before impact. If we substitute, we get u is equal to 5.14 meters per second. Now in part B, they want us to calculate the speed of the ball after its impact with the plane. So in this case, we need to consider the movement of the ball after its impact with the plane. So after it hits the plane, it rebounds to a height of 60 centimeters. So we consider the ball moving up from 0 to 60 centimeters. And we have the formula U1 plus K1 is equal to U2 plus K2. Now here, the ball starts at a height of 0, so we can cancel U1 out. And as it's rising, it's decelerating until it reaches a velocity of 0, and that's when it hits the height of 60 centimeters. So we know that K2 is equal to 0. That leaves us with K1 is equal to U2. If we substitute, we get half mv squared is equal to mgh, where h is 60 centimeters. If we substitute, we get v is equal to 3.43 meters per second. Part C wants us to find the coefficient of restitution. So the coefficient of restitution is equal to v over u, or the velocity after impact versus the velocity before impact. So all we have to do is substitute, and we get 0.667. Give you guys a minute to solve basic question 8. Okay, so part A asks us to find the coefficient of restitution. As we said, it's equal to v over u, or the speed after it collides versus the speed before it collides. So we get 9 over 12, which is equal to 0.75. Part B asks us to find the kinetic energy lost by the ball due to impact. Now, when we're trying to find the kinetic energy gained, we usually do kinetic energy final minus initial. But in this case, they want lost. So we do kinetic energy initial minus kinetic energy final. Initial, the speed is u, and final, the speed is v. So we get half mu squared minus half mv squared. This is v and this is u. So we just substitute and we get 12.6, and the unit is joule.
Okay, so for this one, you just have to not get confused. If you want to have a diagram, it might help you, because it's easy, but you just have to keep focus, I guess. So this one's A, this one's B, this one's C. They're not going to be asking you like with all of them interacting together. It's just going to be A, B, B, C, and so on. So yeah, this one's mass is what? Is 1. I picked it to be A, so it's going to be 1. This one is going to be B, so it's going to be 2. This one's going to be C, so it's going to be 2. And blah blah, the coefficient of restitution is going to be E, the value E. I mean, not the value of E, it's going to be the symbol E. It's like, you know, how we could say the distance x is x, or, you know, it's funny when it's the same name, but, or the same variable name, but anyways. So B and C are initially at rest. This is really important. And what else? A is projected towards B as expected, so A is going to initiate everything. A is going to bump into B, and it will rebound. B will bump into C, it will rebound, or maybe it could possibly continue walking, or rolling. So yeah, A will have a velocity initial, it has an initial of 6. It will have a rebound of, okay, so before I write the rebound, I'm going to pick this to be positive. So this will be positive. These are 0, so I can ignore it. This one's going to be positive. Here it will be negative, minus 0.5 as it rebounds. And we're done with the given, I guess. So find the speed of B, conservation of linear momentum, MA UA plus MB UB equals MB MA VB VA I just can't speak and write, I guess. MB VB, and then just solve for B. So VB equals, I'm going to substitute instantly, so it's going to be 1 times 6 plus MB, which is just 2, times 0 minus because you take this to the other side, so minus the mass, A, so it's 1 times the velocity of A, which is minus 0.5, so this will be plus 0.5, because minus, over the mass of B, which is 2. Let's see what you get. So 6 plus 0.5, basically, over 2, 3.25 equals 3.25 meters per second. Calculate the value of E. We're going to use Newton's law of restitution. E equals, or if you want, let's go step by step. VA minus VB equals minus E into UA minus UB. I'll distribute the minus and solve for E. So VA minus VB over UB minus UA. And so, again, for those of you who want to see me substitute, so VA is going to be, man, my Bluetooth speaker, I don't know, it keeps interrupting. Anyways, you guys won't be hearing this, but yeah. VA is what? We said VA is minus 0.5. It's distracting me. Anyways, UB, we just got VB, I mean, is minus 3.25 over UB, which is 0, minus UA, which is 6. You're going to get minus 0.5 minus 3.25 over minus 6. So you get 0.625. Again, feasible number between 0 and 1. Find the speed of C after the second impact. Now this needs a bit more work, since you're going to have technically a system to work with. So let's start with conservation of linear momentum. So the first thing you'd want to do is the following. Okay, so even though we have the speed after the first collision, it will be basically different. Like, you basically have U. Yes, you have your new U. I'll write it here to the right side. So you have U equals, it's just annoying me because the thing ends. U equals 3.25 for this collision, B and C. And your U here is 0. But you have absolutely nothing about VB and absolutely nothing about VC. You have two unknowns, two tools, Newton's law of restitution and the conservation of linear momentum. Let's start with the conservation of linear momentum. Let me bring that down. Let me just not bring it too down. Anyways, so let's try the equation. So I'll start with the finals. You know how initial blah blah equals final? I'll start with the finals because the other one starts with the finals and I want to line them up. So anyways, so it's the mass MA. If you want, I'll do it step by step. VA, or actually working with B here. So MB VB plus MC VC equals MB UA UB. It's just hard getting the names right, and MC UC. And this is where we'll substitute. So MB is what? It's 2. VB we do not know. Plus again 2. VC again we do not know. This will be just simply 2 times UB. It's not this, it's this. We just got it before, or I mean after the collision. That will be its initial, or you could say it's better before the BC collision. That was its speed. So yeah, MB, so that's 2 times the initial, which is 3.25, plus 2 times 0. So it's 0. And this is just going to be, actually no need, just divide. So VB plus VC equals 3.25. Now time for Newton's law of restitution. Newton's law of restitution, so VA minus VB equals, we just found E, so just use it, 0.625 into UB, or UA actually, since I start with A. UA is what are we saying here? UA is, or actually, let me just use the correct notation. We're talking about B and C. Picked it like that. So we're going to talk about UB. UB is 3.25. And UC is going to be 0. So minus 0. So this is basically going to be minus 0.625 times 3.25. Should get minus minus 2.03125. Yeah. So minus 2.03125. I'll just keep writing all the digits, which is basically all this. Like it doesn't, like it's rational basically. It stops here. Anyways, just for accuracy. Again, my speakers keep interrupting. Anyways, just add them up, so they will cancel. So it'll be 2 VB. These two will cancel if you add them up, this and this. Yeah, and then just add these two up. So it's going to be this, the minus 2.03125 plus 3.25. You're going to get 1.21875. Divide by 2. You're going to get 0.609375, blah blah. So it's basically approximately 0.61 if you want. But we want VC, I guess. We want VC, right? Let me double check. We want VC after collision, the speed of C. Easy. We have this and this and this. We can use any of them. So VC will be equal to 3.25 minus the 0.61. You can do this in the calculator. 3.25 minus 0.61. You get 2.64, which is correct. And so actually you could avoid this by multiplying by, say, negative here, so everything is reversed and you add them up. Instead you'll be cancelling these two, and these two will add up perfectly and nicely to get VC. But I just showed you that you can get both easily and whatnot. So yeah, and since they're asking for C, if you get C first, you don't have to substitute for B. And this is just it.